Okay, so for those brave seventh graders who are looking to get ahead, and even for other middle schoolers who haven't learned this yet, looking to get ahead and you want to learn how to simplify radicals. In this video, we're just going to focus on square roots type of radicals, meaning a square root radical is one that looks just like that. It's understood to have a 2 right here, which tells us that it's the opposite or the inverse or the reverse order of squaring something, raising something to the second power. So we're going to focus on square roots. We're also just going to focus on square roots of numbers. We're going to focus on square roots of just numbers. We're not going to talk about binomials or monomials or any exponents or variables right now. We're just going to keep it simple. This concept, though, this skill we're going to talk about, if you think about it and truly take it in, I promise you it applies even to those hard ones. So let's practice this foundational skills now. Essentially, there's a shorter way and there's a faster way when you are simplifying radicals. Simplifying square roots is what we're going to focus on. Square roots meaning a radical where it's a root of 2 like I just wrote. The fast way is, take a look over here at the way that they're doing it. The fast way is, let's say you have square root of 18. Unfortunately, square root of 18 is not a perfect square, and this is what the whole point of simplifying is. When you have a non-perfect square, you try to take the square root, we know it to be an irrational decimal that goes on forever, so we have to resort to rounding. But if you want to avoid rounding, if you want to write the precise answer, you're going to learn how to simplify radicals, because by doing so, you're able to write it in a simpler form. I'll explain how to get that answer in a minute. You write it in a simpler form, but you don't have to round. So you simplify, it's kind of like simplifying fractions essentially, and you just wrote it down in a full proper form where you have not rounded. So you still have the precise answer. So when you get to advanced mathematics and you go to use certain radicals, you want to simplify them before you can use them to save yourself time. Sometimes you do this in the end of an Algebra 1 course. Sometimes you touch on it in a geometry course, but you definitely do this in an Algebra 2 course, Algebra 2, and in a pre-calculus course. Okay, so long story short, we're going to simplify and give us the exact answers. So if you have square root of 18, the faster way is this. If you have square root of 18, you simply factor it, and your goal is to factor it and look for perfect squares in its factors. So just like a factor tree from back in the day, if you got 18, I'll even throw a square root over it. If you got 18, just like you learned how to factor way back when, you want to see what goes into 18. So you could say 9 and 2. I'll choose the ones they chose. 9 and 2. Now, 2 doesn't go any further, so we're going to stop at the 2. But the 9 does. However, the 9 is a perfect square, and technically, the 9 and the 2 are still under the radical, because 9 times 2, square root of 9 times square root of 2 is square root of 18. We know the square root of 9. We know the square root of 9 to be 3. So that means once you know the square root of something, it's no longer under the radical. So the 3 is on the outside, but that square root of 2 that can't go any further, unfortunately he's on the inside. So it's going to be 3 on the outside times the square root of 2. Now if you don't believe this, you can take a calculator and you can check this, and you'll find that you'll get the exact same answer. For example, if you type in, just to check yourself, make sure you're not crazy, and this is also a way you can check yourself when you're doing it, if you just type in the square root of 18. So I'm opening up a calculator right now. So 18 square root. That tells me 4.24. I'm going to say approximately 4.24. That's the decimal answer of how we would write it. Now, if you did this 3 times square root of 2 down here, you would do that by doing first square root of 2, and that's about 1.41. I'm leaving that on the screen. And I'm going to hit times 3, since there's times 3 in front of it. And now that answer comes out to 4.2426, whatever, but it comes out to the exact same answer, approximately 4.24. So if you're ever not sure if you simplified it correctly, compare it to just taking a calculator and find the real square root, well not the real square root, but the decimal rounding square root of square root of 18, or whatever the number may be, and compare it to what you simplified it to. It's a great way to check. Okay, so back to my original point. Looking for perfect squares inside of your factor tree, that's the fast way of doing the simplifying radicals method, looking for those perfect squares. But now let's backtrack and let's pretend we didn't know the fast way. I'm going to show you kind of the slightly longer way, but it's a way that might make more sense for you guys. It might help. And I call it the evil twin method. Or some people call it the friends method. So I'll refer to it as both if that helps. Alright, so when you do still do your factor tree, but here's what you do. With your factor tree, you no longer look for perfect squares. Your goal is just to factor it completely, meaning getting the prime factorization. factoring down until you can't go any further. So 18 is 9 times 2. That is not a 2. Excuse me. 9 times 2. 2 is done. Well, 9 is 3 times 3, and now the 3's are done. So here's what you do. You look at your prime factorization, meaning you look at all your numbers. You have a 3, and a 2. Here's what you're going to do. Some people call it the evil, some people, meaning me, call it the evil twin method, meaning you're looking for twins. So if you look, we have a twins of 3's. We have 2 3's in our prime factorization. So because we have 2 3's, they essentially join forces and they break out of jail. So the square root is almost like being in jail. So when you have an evil twin, you have someone to match up with, or even call it a friend, you get to break out of jail. So, but when you go out of the jail, you essentially combine. There's only one. So when you're on the outside, there's only one of where there was 2 on the inside. And unfortunately, that 2 doesn't have any friends or an evil twin. So a 2 is still on the inside. So because the 3 had a twin, the 3 was outside. Another way of looking at this, instead of the evil twin method, some people call it, if you have a friend, you get to go outside and play. Like if you're in the house, you want to go outside and play with your friends. You need a friend, in this case, one that's just like you, so that you can go outside and play. And so you can leave the house being the square root. So if you have a friend, you can go on the outside, but when you go on the outside, only one of you shows up. Now, and intuitively, the reason why that is if you have 3 times 3 on the inside of the square root, that means 9. And it's back to our original point. What is the square root of 9? Well, it's going to be 3. So that's where we got that 3 on the outside. So some people like looking for the perfect squares as they're going through it. Some people like to just factor all the way and then look for doubles, or look for twins, or look for friends, and then they do it that way. So I'll do it a little bit of both. I'll kind of bounce back and forth between those two methods. You choose which one works for you. They both always work. Because sometimes, let's say for this question you hadn't done 9 and 2. Let's say you had done 6 and 3. And then you had done 3 and 2. Now, if you had done the 6 and 3 method, you never would have seen the perfect square of 9 and 2. You would have just seen the 6 and the 3. Then we've gone further for the 6. Now, if you had done it that way, you still would have said, well, I have a double of 3's. So because I have a double of 3's, they're going to be on the outside. Unfortunately, my 2 doesn't have a friend or doesn't have a double, so 2 stays on the inside. So you would still get 3 times square root of 2. So no matter how you factor it, sometimes the doubles method or the twins or the friends method, whatever you want to call it, that way sometimes works more because sometimes you don't see your perfect squares inside of your factoring tree. Alright, so that's how they did the examples. Now we're going to go through each of these exercises, and if you think you understand, press pause and try each one before we do it, and give each one a shot on your own. That's what I want you guys to do. So I'm going to erase this one, and then we're going to take a look at exercise 1. So press pause and try exercise 1 on your own first. Okay, so hopefully you tried exercise 1 on your own. So I set up square root of 12. What gives us 12? Well, that makes me think of 4 and 3. 3 cannot go any further, so we're done with the 3. What gives us 4? 2 and a 2. So now you notice in this method I was just going all the way to the prime factorization. Now I'm just going to look for doubles. I see a doubles of 2, so that means 2 is on the outside. I do not see a doubles for 3, so 3 is still on the inside of the house. He does not get to leave. So it's going to be 2 times the square root of 3. And so that's going to be our answer for number 1. Our answer for number 1 is going to be 2 times the square root of 3. And now take a chance to take a moment to think about that, and feel free to check out the calculator by doing square root of 3 first, and then timesing by 2. And that'll equal the same thing as if you had just done square root of 12. It'll give you the exact same answer. Alright, now move on to number 2 and try number 2. Well, and I'm going to erase number 1 while you're doing that. Oop, that would not be the eraser. Alright, so make sure you try number 2. Press pause if you haven't done so already. Alright, so square root of 8. Square root of 8, that's 4 times 2. 2 is all the way done. And we actually know the square root of 4. We know the square root of 4 to be a 2, so that means we're going to have a 2 on the outside. Unfortunately, that other 2 didn't have any friends, so he has to stay on the inside. And if you're not sure what I mean, let's go all the way through and finish this question. Remember, 4 and a 4 is a 2 and a 2. So if you had done it this way, you'd gone the prime factorization way, that one extra step, you would have said, hey, I have 3 2's. But remember, we can only do doubles. So it doesn't matter if you choose these 2, or if you choose the 2 on the left, or the 2 on the left and right. As long as you pick a double. And remember, every time you have a double, it shows up on the outside as just one of them. So there's only 1 2 on the outside. then unfortunately that 2 that didn't have a friend or didn't have a double, he stays on the inside of the house. So he stays on the inside. So that's why you see him still in here. So we still have 2 times the square root of 2. And that's going to equal the exact same thing as the square root of 8 if you check it. On your calculator, you do square root of 2, then hit times 2. Okay, now take a moment to think about that. Maybe write it down, give yourself some tips. Then I want you to try number 3. Alright, hit pause if you haven't done already. Do number 3. Alright, 27. Well, that's 9 times 3. By the way, this is where your timetables come into play here. That's 9 times 3. 3 is as far as it goes, but 9 goes further to 3 times 3. So just like the last question, we have 3 of a kind, but again, we can only take doubles. So I'll take the first 2 in this case, so that means there's 1 3 on the outside, and unfortunately that other 3, he doesn't get a friend, and so he stays on the inside, because he doesn't have a double or a friend. So that question, the answer to that question is going to be 3 times the square root of 3. Take a moment to think about that, and then I'm going to scroll down and I'm going to do some more questions. But of course, I want you to try them on your own as well. Alright, so now give square root of 20 a try. Even try a few of them if you want, and then I may not end up doing all of them, but I'll just try to make sure you get the answers for all of them to check yourself. Now you'll notice I set up for both number 4 and number 5. I'm going to kind of leave them both on the screen at the same time. So if you haven't done so already, hit pause, try number 4 and try number 5 before you watch these, because I'm doing both back to back. Alright, so square root of 20. Well, 20, that's 5 times 4. 5 can't go any further, but 4 can. We actually know the square root of 4. It's going to be 2, so that already tells us we're going to have a 2 on the outside. But if you're not sure, we'll go ahead and see it all the way through. Do 2 times 2. And like we said, if you have a double of something, you show one of them on the outside. Now they're on the outside of the house. But unfortunately, the square root of 5, he doesn't have any friends, so he stays on the inside. I say unfortunately jokingly, by the way. I don't really mean 5 is lonely. 5 is a fantastic number. I think you know what I mean by, is there a double? So the answer number 4 is 2 times the square root of 5. That's how we would simplify that. That would be the exact answer to that question. Alright, square root of 54. Square root of 54. I know that 6 goes into 54, and I know that 9 goes into 54. Now, if you didn't realize that, you at least can tell that 54 is an even number, so you at least could say 2 goes into it. How many times? You'd say 27. So you could do 2 and 27. But just for the sake of spreading it out, I'm going to do 6 and 9, because 6 goes into it 9 times. 6 and 9. Well, 9 is 3 and 3. 6 is 3 and 2. And yes, you could have said, once you had 9, you could have already said, oh, I know the square root of 9, that's a perfect square, so that already tells you you're going to have a 3 on the outside. So now in this question, I see a double of 3's. You didn't have to choose those 2 3's. You could have chosen the first 3 and the second 3. You could have done that, but it doesn't matter as long as you look for doubles. So because there's doubles of 3, that means there's a 3 on the outside. Now notice, the other 3 and the 2 do not have doubles. So that 3 times 2 is still on the inside because they did not have doubles right here. So now, because we're on the inside and we're at our final step, you just have to multiply anything that's still on the inside. So 3 times 2 is 6. So that tells you you're going to end up with 3 times the square root of 6. That's what that's going to become. 3 times the square root of 6. And again, if you're not sure if that's true, on your calculator, with your basic 4 function calculator, type in square root of 6, take that answer, hit times 3. Whatever that is, that'll equal the exact same thing as if you had just hit the square root of 54 to begin with, which is going to be 7 point something. I'm going to guess, say 7.4, 7.5, right around there, because I see that 54 is a little bit bigger than 49. That's a way to estimate. Take a moment to think about those, write those down if you didn't do so already, and make sure you're doing okay while I erase them. Before I go on, I want to make a point and do a quick what if. Let's pretend we were factoring whatever up here, it doesn't matter. That's just a question mark. Let's say that when we were doing our prime factorization that we had gotten another 5 out here. Let's say there had been another 5 out here. If that had been the case, we would have had a double of 5s. So what we would have had is on the outside, we would have had the 2 that was already there, but now we would also have a 5. And in this question, we wouldn't have anything left on the inside. We would just do 2 times 5 is 10. So that means our answer was 10, meaning the square root of whatever it was would have been 10. In that case, it would have been 100. This is what will happen if you factor a perfect square. You'll end up with having nothing left on the inside because there'll be a double for everything, and then you'll just multiply whatever's on the outside of the house, and that's your answer. Or additionally, let's say we were factoring it and we came up with also a 6 when we were factoring. Let's say there was also a 6. Now, the 2 and the 5 would still be on the outside, but the 6 would not have a double, so the 6 would be stuck on the inside. So the 2 and the 5 would give you 10, and the square root of 6 would still be on the inside. And so the number it came from doesn't matter. I just want to let you know when you're factoring these that's kind of what you do. Is you keep going, you look for any doubles. You can have two things on the outside like this, and you just multiply them together. Or you can have two things on the inside, like we had in that last example where we had 3 and 2, and that gave us a 6 we had. So I just want to put that thought out there. So think about that. All right, so give it number 6 and number 7 a shot. Press pause and make sure you try those. I'm going to spice up with some different colors. So 72, I know that 9 and 8 go into 72. So that tells me 9 and 8, and then 9 is 3 and 3. We could have said we know the square root of 9, so it means we have a 3 on the outside, or you're welcome to just go all the way through and look for doubles. 8 is 4 and 4. I'm sorry, 4 and 2. So that tells us we know that there is a 4. We know the square root of 4. We know that to be 2, so that means there's going to be a 2 on the outside. Or if you don't like that, like I said, just keep going, do the prime factorization. Now look for doubles. I see a double of 3s, and I see a doubles of 2s. I made a point to grab those two. It doesn't have to be the two next to each other. So that means you're going to have a 3 on the outside. You're also going to have a 2 on the outside. But unfortunately, that other 2, he does not have any friends. So he's still going to be on the inside. So the 2 is still going to be on the inside, but the 3 times 2 is going to be on the outside. And 3 times 2 is 6. And then the 2 is still on the inside. So 6 times the square root of 2. That's what you're going to end up with for number 6. Alright, square root of 300. Now, you may not know the biggest thing that goes into it, not the end of the world, but as long as you take your time to think about something that goes into it. I see a 3, so I know 3 goes into it. I see hundreds, so I know 100 goes into it. I see 30 and 10 go into it, so it doesn't really matter what you choose. So I'm going to choose, let's say, 3 and 100. I'll say 3 and 100. 3 does not go any further, but 100 does. 100 is 50 and 2. 2 doesn't go any further, but 50 does. 50 is 25 and 2. 2 doesn't go any further, but 25 does. 25 is 5 and 5. Now those 5s go no further. So now you're at the step where you're looking for doubles. So I see we have a doubles of 2s, so that means there's going to be a 2 on the outside. I see a doubles of 5, so that means there's going to be a 5 on the outside, so 2 times 5. Unfortunately, 3 does not have a double up here, so 3 is going to be stuck on the inside. So I squeezed it in over there. So 2 times 5 is 10, and then the square root of 3 is still going to be on the inside. So the answer to this question is 10 times the square root of 3. That's the answer to number 7. So take a moment to think about that, and then I'm going to erase them. Okay, give number 8 and number 9 a chance, and then hit pause and make sure you can prove it. Or if you've already done the next 3, at least let's go ahead and now we can start checking them. So 24 is 6 and 4. 6 is 3 and 2. 4 is 2 and 2. So now I see doubles of 2s. It didn't have to be those 2, as long as you choose doubles. That means there's a 2 on the outside. The 3 and the other 2 do not have doubles, so they're still on the inside. That 2 and that 3, they're still on the inside. Well, 2 times 3 is 6, so that means we have square root of 6 on the inside, and that 2 is still on the outside. So that means that's 2 times the square root of 6. That's how you simplify the square root of 24 for number 8. Now, to continue over here, if you have 45, well, 45, that is 9 and 5. 5 does not go any further, 9 does. 9 is 3 and 3. Or you could have just said, I know the square root of 9. It's 3, so I'm going to have a 3 on the outside. You could have done it that way. Alright, so we have a doubles of 3s. So 3s are on the outside. 5 does not have any doubles, so 5 is still on the inside. So that tells us the answer is 3 times the square root of 5. That's how I simplify square root of 45. And just as usual, if you didn't factor yours exactly the same way I did, that is perfectly fine. You could have done 12 and 2 here. You could have done 3 and 15 here. That is fine. It's just, no matter how you do it, if you're factoring it, you're still going to end up with the same answers. So take a moment to think about these, maybe copy them down if you had some trouble. But hopefully at this point we're getting some practice, we're starting to get the hang of it. And then hold yourself, we're about to do number 10. Alright, so this is going to be our very last one. We're going to do the square root of 50. So make sure you try this one on your own first. Square root of 50, I think 25 and 2. Maybe you thought 5 and 10, doesn't matter. 2 does not go any further, but 25 does. 25 goes to 5 and 5. I now see that we have a double of 5s. because we've gone all the way, so that means there's a 5 on the outside, and we do not have a double of that 2, unfortunately, so he's still on the inside. So that means we have 5 times the square root of 2. That is the simplified version of number 10, of square root of 50. So hopefully now you've gotten pretty good practice. Maybe you're feeling confident, but at this point we've done a bunch of examples of different types of simplifying square roots, and the point of that was, remember, all of these are non-perfect squares, so if we had done the decimal version, we would have had to round, which means we would no longer have the precise answer. This isn't a skill you necessarily need specifically for 7th or 8th grade right now. It's kind of an advanced skill. But it's something that if you want to get a head start, or if you just want to start thinking about it so you already know what it looks like, or if you want to be able to show off and impress your friends and your family, let them know you know how to do, you've gotten ahead, you've got some skills that are used in higher level mathematics. Or let's say you're a high school student going back and now you're learning this for the first time. Hopefully this helps you out with what you're going to do. So now, you can stop the video here, but if you want to see an extra challenge for the stuff I talked about, with maybe square roots with some variables and some exponents, stick around and we'll try some of those. But at this point, the part of the video on just simplifying regular old square roots, that part is done. So if you're satisfied with what you've learned, you're welcome to stop here. But if you'd like a challenge, stick around for a challenge. Because now we're going to talk about how to do the square roots of variables and exponents is what we're going to do now. So let's make one up. Let's say we had an example like 36x squared. Let's say we want to find the square root of that, 36x squared. So we're going to go to factor that. Well, what gives us 36? 36 is 6 and 6. So actually we know the square root of 36. The square root of 36 is 6. So yeah, you can turn these into 3's and 2's, 3's and 2's, or just realize 36, the square root is a 6. We have doubles of 6's. So that means on the outside of our radical, we already know we're going to have a 6 out there on the outside. Now let's do x squared. The factor x squared, what gives us x squared? Well, that's x times x. Well, hey, that's doubles again. So because we have doubles of those x's, we're going to have one x on the outside, so 6 times x. And just like earlier, there's nothing left who doesn't have a double or an evil twin or a friend to go play with, whatever you've been calling it. So there's no more radical, there's nothing underneath it. So whatever we have on the outside is our answer. It says 6 times x. Well, that's just 6x. So that means the square root of 36x squared, the square root of that is 6x. If you're not sure, check yourself. If you did 6x times 6x, 6x times 6x, well, 6 times 6 is 36. X times x is x squared. Well, hey, that gave us what we had on the inside. So that checks out. So this is an example of simplifying a radical with variables and exponents. Now let's do another one. I'll try to squeeze one right next to it. I'm not going to have it in my life. Let's erase that. If you needed to, hit rewind and write that down. That might help you out. Let's do one where it doesn't simplify all the way like that, where they don't have perfect square roots. So I'm going to steal a similar one to one we did over there. No, I don't want to choose one we already did. So let's see. Square root of. Alright, so let's say you have the square root of 52x cubed. You want to simplify that square root. Now let's start with the number portion, 52. When I see 52, maybe you know that 13 goes into it, maybe you don't. Maybe you at least know it's an even number, so 2 must go into it. So you could say 2 and 26. And then for 26, you could say 13 and 2. 13 does not go any further, neither does 2. But you might notice, hey, I've got doubles of 2's right here. So that means I'm going to have a 2 on the outside. But then, unfortunately, that 13 did not have a double, so that 13 is still going to be on the inside. But now, don't forget, we have to go factor the x cubed now. X cubed. What gives us x cubed? Well, x and x squared give us x cubed, because x times x squared. That means we have 1x right here, and we have 2 x's here, and so altogether we have 3. So x times x squared is x cubed. So now x doesn't go any further, but x squared does. X squared goes down to x and x. So now look for your doubles. I see 2x's here in our prime factorization, so that means there's going to be 1x on the outside. Unfortunately, the remaining x did not have a double, so he's going to be stuck on the inside. So all you got to do now is simplify the outside, simplify the inside, and you're going to have your answer. So on the outside, we have 2 times x. Well, that's just 2x. On the inside, we have 13 times x. Well, that's 13x. And so that's going to be our answer. Our answer is 2x times the square root of 13x, or sometimes it's just pronounced as 2x square roots of 13x. So that's a simplified version of square root of 52x cubed. This is the simplified version, whereas some of it ended up on the outside, but some of it was left over on the inside. So they were not perfect squares, either of them. So this was a challenging question. Maybe write it down and use it to review from. Okay, I don't want to spend up all the video doing challenge questions, so I'm only going to do one more, and then after that, we're going to call it quits, because we may be pushing a little too far for 7th grade, but also maybe a high schooler is watching this, you might be getting help from it as well. So let me make up one more question. We'll make this one a little bit harder, so that we can get one last final push to practice and challenge ourselves. Okay, so this is going to be our last one. I tried to make it a doozy where it's quite a bit longer using the challenging skills we've talked about. So press pause, challenge yourself, truly give this one a shot if you've been keeping up until this point and watching how to do simplify square roots. And this one, it's not going to be a pretty answer, but it's one that's going to force you to make sure you organize yourself, you're following the steps, and you're simplifying it fully. I'll give you a chance to start that. Press pause. Okay, so let's start with the number, 315. It might not be obvious what goes into that, but you see it ends in a 5. So if it ends in a 5 or a 0, we know that 5 must go into it. So for this one, a 5 does go into it. So if you do 315 divided by 5, you find out that it goes into it 60-something times. So 63 times. So you have 5 and 63. 5 does not simplify any further, but 63 does. It does not factor any further. That's the proper term. 63 does. 63 factors down to 3 and 21. 21 goes into it 3 times. Now 21 factors down into 3 and 7. So you factored 315 all the way. So you might notice already you have doubles. You have a double of 3. So that means you're going to have a 3 on the outside. Unfortunately, you're still going to have a 7 times 5 on the inside. They did not have doubles, so they're going to be stuck on the inside. So you're done factoring the 315. Now your job is to factor all the letters. So if you have x to the 5th power, well, that's going to be x squared and x cubed. Well, x squared is x and x. I really should have used a different color for this. X squared is x and x. X cubed is x and x squared. Well, x squared is x and x. So we now have gone all the way with the x's. I apologize for doing that in red. I'll make sure I change colors for the next one. So that means we look for doubles of x's. I see a double right here of the x's, and I see a double right here of the x's. So that means there's 2 x's on the outside. That's what that tells us. There are 2 x's on the outside. I'm going to need to erase that and slide that over. So let's keep track of the outside. The outside, we said we had a 7 and a 5. No, I'm sorry. We have a 3 on the outside. And now we just said we have 2 x's on the outside. Now way over here, I'll deal with the inside. On the inside, we have a 7 and a 5. That's still on the inside. So we've now done the x's. Now let's do the y's. Y squared, well, that's y fourth. I'm sorry, that's y squared times y squared. Well, each of those is a y. So we have a total of 4 y's. So that means we have 2 sets of doubles here. So that means we have 2 y's on the outside. That's what that tells us. So that means there are no more leftover y's to go on the inside. They're all on the outside. Now last but not least, if we do z cubed, well, that's z times z squared, and then z squared is z times z. So now we look for our doubles, and we have doubles of z. So that means we have 1 z on the outside. But we have, unfortunately, that lonely old z, the other z, who did not have a double or a friend, so he's still going to be on the inside. So now, on the outside, let's recap. Let's look for all of our doubles. Let's double check. We had doubles of 3 over here, so we had a 3 on the outside. We had 2 doubles of x's, so we should have 2 x's on the outside. We had 2 doubles of y, so we should have 2 y's on the outside. And as I did that, I just realized we missed one of the x's right here. He did not have a double, so that x is still on the inside. So this is going to look really sloppy and lazy, but I'm going to squeeze him in right there. We have a times x in there, because we realized he didn't have a double, so we missed one. And don't forget, when we went through, we saw that we had the 5 and the 7. That's where those came from to go on the inside. All right, so we still have this x on the inside because he didn't have a double. We got our y's on the outside. We see that we had one double of z's, so we should have one z on the outside. And then we had a z that did not have a double, so that means we should have one z on the inside. So now we're ready to just simplify everything, and once you do, you will have your final answer. We see on the outside, our only number we have is a 3, so that means we have a 3 on the outside. That'll be our coefficient. We have x times x. Well, x times x is x squared. We have y times y. Well, that's y squared. We have just a z, so that's just z. Now, on the inside of the radical, we have 7 times 5, which is 35. And I cannot believe I am out of room. I'm going to have to erase and write this more neatly. So, take a moment to jot some of this down, but I need more room in order to write down what this gives us. So here's what I'm going to do. Actually, to save us time and so I don't have to erase it, I'm going to write it at the very, very top. So let me get cut out real fast. Okay, so that's 3x squared times 3 times x squared times y squared times z times the square root of. On the inside, we still have 7 times 5, which is 35. And then we have an x and a z. So that just means times x times z. And you should put those letters in ABC order. So that's going to be our final answer for this question. That's going to show us that out of all the simplifying and putting all the ones on the outside, I don't mean to laugh, but this question took quite a bit of effort. I didn't realize it when I made it. So what we're going to do, this is our final answer. Your final answer is 3 times x squared times y squared times z times the square root of the quantity, 35 times x times z. So that is the final simplified answer of our original question for simplifying, and that was definitely a doozy and a challenge. If you truly got square roots and simplifying square roots with monomials like this, where we just have nothing but multiplication and exponents of variables, you've got this. So if you stuck through me with this, you're a champion. I'm proud of you. But congratulations, guys. At this point, you're probably pretty good at simplifying radicals. Hope this has helped everyone out there. Good luck and take care.